Welcome back, everyone, to another episode of Thin Clients. Now, this doesn't necessarily look like a thin client, but it is a derivative. So, this is something I ended up assembling on my own, and one of the reason is I really like this acrylic case that I can get just easily from Amazon or eBay, not Amazon. And just kind of got it. I had the thin client laying around, and that thin client had two very important things. It was a mini ITX, so it would fit perfectly in this case, and it had a 19-volt power input instead of a ATX power input, and so I don't have to use those pesky um, Pico ATX power supplies. I don't really like them. So, what is this thin client supposed to be? It's a VXL ITONA TC6764D. Um, no, not D. So the D one is J1800. This is a J1900. That's the only difference. But I could only find the product like brochure for the D variant. So this is what it's supposed to look like. That's the rear I/O. What we are missing is a parallel port. I think the serial port um, and that serial port over there. Otherwise, all these ports are spread out into a header on the motherboard itself. So you can just buy an off-the-shelf parallel port header and attach it, and it'll work just fine. Um, Again, it says quite a lot up there. So DDR3 1333 megahertz. I have an 8 gig stick there that works fine. Seven USB ports, including one USB 3. One of the interesting things about these USB 3 ports on the Bay Trail platform is that they are um, sort of OTG, UHC, I think UDC compliant. So it's like where it can emulate another device. So you can have CDC, ACM serial on there, or emulated master storage or things like that. I've never played around with it too much in Linux, but now that I have this box working, I'll try it, and maybe I'll do a video on that at some point. So we have one VGA, one HDMI port, dual display, and I guess that's about it. There's not much to it. Now they say it's a Citrix receiver, VMware receiver, RDP, blah 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 blah, and just that's just what they ship with. I have, of course, Debian installed on it, which is the same version I use for PTS. So for our next test suite is on there, and we'll look at that later on. Apart from that, not much. Just you have your keyboard and mouse, and so let's look at the actual device, and we'll talk about that. So for the actual build, this is what the I/O that is available to us is. There's a VGA port, there's an HDMI port, there's audio, networking, four USB, USB 3, separate keyboard and mouse for PS2, and a 19-volt power plug in. And so that's actually pretty neat. So let's open it up and see what's inside. You can see what's inside, but let's have a clearer look at what's inside. Right, so the way this case opens up is just lift it out, and it's notched over here and all the four walls. That's how it's sandwiched and then just held by four screws. Seems to work well. So this is the main hardware. It has, in one of the better features I like about it, as it actually has SATA power here, which makes it really easy to add a SATA drive. Usually in the previous Dell Wise videos, you've seen that there's no SATA power, and it's usually they have like an embedded SATA port or a SATA DOM port, or just pins for power that you have to hack into to get it into a proper SATA drive. They do sell like accessories which convert like non-SATA power ports to SATA power ports, but that's an add-on. And sometimes when you're buying it from a third-party vendor or like a second-hand market, you don't get that. So here's a hard drive removed. So you have a SATA power, you have two SATA drives, you have a slot for the mini PCIe for Wi-Fi, I don't think NVMe will work on it, but that's something I've not tried. You have a fan header, which is kind of interesting that it has a CPU fan header. It's very low power. It's a quad core Celeron J1900. It is extremely low power. It doesn't need a fan, so I'm guessing that's probably for like a case fan situation. But eh, doesn't really need it. There's a system fan again here, so that's a CPU fan. No, right? It says CPU fan, but there's a system fan header right there, so I can remove this. Your front panel header, and that's the parallel port connection. Couple of serial ports right there that go out there that we've already seen. LDC is here. Couple of USB ports are there. So not nothing much doing. This is front panel audio. So pretty decent layout for a single board mini PC setup. Interestingly, they actually have a variant with ATX power. This one's just not populated. So, so they'll probably sell two motherboards. ECS is the vendor, and they are the ones probably selling these motherboards to ITONA or VXL. You have a single stick of DDR3 memory. I have 8 gigs installed, and that works fine. Uh, Feature wise, there's nothing else. It's a very basic, bare bones motherboard based. Like it's a proper PC first, and then that was adapted into a thin client rather than it being a thin client specific hardware. So let's take a look at the CPU. It's a full-blown SoC, so all the GPU bits are going to be in the same chip. These clips are extremely powerful, and so yeah, I've tried to repaste this board at some point, and I use a bit too much thermal paste, it seems. Let's clean it up and see how the SoC looks like. Right, so here it is cleaned up as much I wanted to clean it up. Didn't really go through with it. But the SoC itself is pretty bare bones. There's no markings on the sock, just a square die, and that's about it. So there's really nothing on there. Even the substrate just has some numbers, as you can see there. Maybe a copyright or two, but that's about it. Doesn't even say Intel anywhere on the except for the I. Doesn't really say Intel anywhere on the whole substrate. So yeah, kind of boring, but that's how these systems are meant to be. A single sock that runs everything, kind of like an ARM based system. All right, it's all plugged in, and actually, I will swap out the SSD for the Debian one, and we'll run this, and I'll show you on the screen capture, and we'll take a look at how this performs comparative to the other Dell Wise systems we've taken a look at recently. Alright, all logged into Debian, booting on the ITONA TC64 ITONA TC6467. Yeah, I could not remember that. Right, so we have 4 cores, and this one, in fact, does have. Alright, so let's look at a few things around the system, and then we'll take a look at the benchmark. On LS CPU, it just shows up as a Celeron J19 at 2 gigahertz. It does boost a bit more than 2 gigahertz. I think it goes to like 2.4, 2.5. And so that's working in its favor. So you can see the maximum boost clock is 2.415, and it does boost on all cores in most cases. Probably not for too long, but still good enough to for most of the benchmarks to be running at full tilt. Apart from that, 64-bit x86, and we have genuine 4 cores. Each core has one thread, so these are 4 actual core. There is no hyper threading in this CPU. These are 4 full cores, um, and it's a bit more modern, so it has a bit more. vulnerabilities in the silicon. So we have MDS and meltdown in the previous hardware. We just had Spectre V1, V2. Right, let's take a look at the Phoronix test suite results for this benchmark. Right, compared to the Wise hardware, it's beating almost every other board, every other mini PC in pretty much every test except for maybe a couple here and there, and we look at the outliers. So for GL Mark II, it's actually not the fastest, which I thought it would be with Intel HD. And like, let's take a look at what GPU there is. So as compared to the Radeon HD 6320, the Intel HD Bay Trail is not that fast. It doesn't really 845 megahertz, but it's not a 2 gig dedicated VRAM. It's still shared with the DDR3 on board. And then you have, yeah, so it's not the fastest. The ZX0 still beats it by quite a bit in GL Mark II. Tiny Membench, it is the fastest. It's still like Tiny Membench is still single core, so it's not hammering the memory with all the cores. That really makes that not that much of a difference. Usually, single core is enough to saturate the bandwidth of a single channel memory. But it's still much faster. Although ZX0 not and 5010 both are on DDR3 platform, and ZX0 actually has dual channel, so it still beats out quite fairly. GMP bench, it wasn't the best again. So for whatever reason, the Sempron CPU seemed to fare better. It's a much lower clock, it's much older, but still it seemed to fare better on GMP bench single core performance, even though the TC6764 was running at like 2.5 gigahertz throughout the test. X264 decode is a lot better. We are seeing 7 frames per second, so we've sort of more than doubled our performance. But then also there are 4 cores. All the 4 cores are running at 2.54 gigahertz. So per core performance is still does it's not scaling as good as you would think. Those AMD cores for ZX0 and 5010 are still pretty good. Dark table, it beats everything else. Dark table seems to have a lot more optimization for newer CPUs, and because it's running OpenCL in CPU only rendering, it ends up utilizing quite a lot of these extra extensions that newer CPUs might have, and just seems to make a lot of difference. But also, it scales in terms of more or extra cores, so it's almost double of the double twice as fast as ZX0 um, in both scenarios. Browser benchmark, it's a bit better, not by a whole lot. So it's not the browser benchmarks aren't necessarily multi-core. They do utilize multiple cores as and when required, but like Firefox itself is complicated enough that it kind of decides and schedules its own threads across the cores, and it doesn't really add up in a way that you'd think. But it's still better than all the three um, thin clients that we have tested so far. So that's about it. Thank you so much for watching. I hope you enjoyed this episode. Subscribe for more, and I will see you all in the next one.